We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear friends, myself is Roshani, Parikh, and today we are going to learn about the Kirchhoffs current law. Now before start to learn about the Kirchhoffs current law, just recall the Ohm's law. What is the statement of Ohm's law and where it's the applicable? So Ohm's law statement is like that कि when a voltage is applied to any network or any circuit, current starts to flow through the network or a circuit. That current is directly proportional to the applied voltage when the temperature remains the constant. That is the statement of Ohm's law, which is represented by a V is equal to IR in a equation form, and it can be used to solve this simple network. सिंपल नेटवर्क को सॉल्व करने के लिए हम ओम्स लॉ अप्लाई कर सकते हैं. नाउ व्हाट इज अ नेटवर्क? नेटवर्क किसको बोलते हैं? तो नेटवर्क इज ऑलवेज मेड बाय यूजिंग द कॉम्बिनेशंस ऑफ ए एक्टिव एंड अ पैसिव एलिमेंट, और यू कैन से ओनली बाय द पैसिव एलिमेंट. जो एक्टिव और पैसिव एलिमेंट के कॉम्बिनेशन से बनता है उसको हम नेटवर्क बोलते हैं, और ओनली बाय पैसिव एलिमेंट से जो बनता है उसको भी हम नेटवर्क ही बोलते हैं. तो इफ अ नेटवर्क is a simple, then you can easily solve by using the Ohm's law. But if a network is a complicated, means a network having a more numbers of active element and more numbers of passive element, at that time the solutions become a difficult by using the Ohm's law. So this difficulty can be overcome by using the Kirchhoffs law. Now Kirchhoffs has 2 laws: Kirchhoffs current law, which is popularly known as the KCL, and other that is the Kirchhoffs voltage law, which is popularly known as a KVL. Now today we are going to learn about the Kirchhoffs current law in a brief. Now what is the statement of KCL? Algebraic sum of current meeting at any node in any network is a 0. Sigma I is equal to 0. Now what is a node? Node means a point at which 2 or more than 2 elements are meet, that is called a node. कोई भी नेटवर्क उसका वो पॉइंट जहाँ पे 2 या 2 से ज़्यादा एलिमेंट कनेक्ट होता है उसको हम क्या बोलते हैं? नोड बोलते हैं. तो किरचॉफ अस पर दी केसीएल क्या है? सिग्मा आई इज इक्वल टू 0 मीन्स algebraic sum of the current meeting at any node is equal to 0. Node is also known by the junction also. Now see here, one network is a given. See A, that is the node. A is also called a junction also. See here, 6 elements are connect at a node A. Now see here, always the current which is flowing towards the node is considered as a positive, and the current which is flowing away from the node is considered or treated as a negative. जो करंट नोड के तरफ आता है उसको हम पॉजिटिव कंसीडर करते हैं, और जो करंट नोड से बाहर निकलता है, नोड से दूर जाता है, उसको हम नेगेटिव ट्रीटेड करते हैं. तो सी हियर, I1 is going towards the node A. Same way I2 is flowing away from the node A. I3 is also flowing away from the node A. I4 is flowing towards the node A. I5 is also flowing towards the node A, and I6 is flowing away from the node A. Now algebraic sum of current meeting at a node is the 0 as per the Kirchhoffs current law. So see here, I1 is incoming, so taken as a positive. So I1, same way I2, that is going outside or a outgoing current, so consider as a negative. So minus I2, So I1 minus I2, same way I3 also outgoing current, so consider as a negative minus I3. I4 is incoming, so taking the positive plus I4. Same way I5 is also incoming, so consider as a positive, and I6 is a outgoing, so consider as a negative. So final our equation sigma I is equal to 0 means the algebraic sum of current meeting at a node A, that should be a 0. So I1 minus I2 minus I3 plus I4 plus I5 minus I6 is equal to 0. That is the KCL. See here, you can write like this: I1 plus I4 plus I5 is equal to I2 plus I3 plus I6. Means what? Okay, the algebraic sum of current flowing towards the node is equal to algebraic sum of the current flowing away from the node. Incoming algebraic sum of incoming current is equal to algebraic sum of outgoing current. That is the statement of the KCL. Okay, sigma I is equal to 0 in any network. The current meeting at any node is equal to 0.